Bismillah ar-Rahman ar-Rahim, and welcome to lecture number 23 for basic engineering mechanics. In this lecture we would start our discussion on structure analysis, which is chapter number 6 of our textbook. And so the topic for today is that we will discuss something which is called simple trusses, and then we will see how we can analyze simple trusses using the method of joints, and then we will see some examples relating to those simple trusses. Okay, so what is a truss? Truss is a structure which is composed of members which are joined at their endpoints. So like this roof here, this roof can be considered to be made out of these smaller slender members, and each of these member is connected to the others at their endpoints. So for example, this truss, this is a separate member, and this one is a separate member, this is a separate member. So each of these members are connected to each other at the endpoints, which are called the joints. So the only connection between the members is at the green spots, which we can call the joints. Okay, these type of structures are very popular in engineering design, because in many practical situations we actually end up with systems which are composed of these slender members, or which are simple trusses. Okay, so for our analysis we would look at something called a planar truss. A planar truss is something which can be drawn inside a plane, so that all the members, they lie inside of a plane. And so here we have given these two examples. This is a truss for a roof, and this one is a truss for a bridge, and these arrows show the external loadings on so these are the external loadings on the bridge, and these are the external loadings on the roof. And other than that there are many practical situations where the structures are basically simple trusses, and I'm sure all of us here would have seen those practical situations. So here is another. You guys might have seen electrical poles which are made something like this. So we have electrical poles, and these poles are also made out of simple trusses, and they have cross trusses in between. So these poles, these structures which have to be made out of trusses are easier to assemble, and also easier to dismantle, because this whole big structure can be broken down into these very smaller structures or members, and each member does not weigh that much, and it's not very long, so it can be easily transported. So that is a practical reason why many practical structures are made out of trusses. Okay, so for our analysis of simple trusses, we would make two assumptions. First of all, we would assume that all of the loadings that are applied on a truss, all of the external loadings, they are only applied at the joints. So any external loading that I can have, so maybe I have a loading something like this, so this loading should be acting at the joint if this is a force. Okay, what we are assuming that we will not be looking at a case where the external loading is acting somewhere on the member, and we will see why making this assumption would simplify our analysis for trusses. The second assumption that we are going to make is that the members are joined together by smooth pins. Okay, so we would assume that each of the joint is basically a smooth pin joint. So that means that these members, they are free to rotate, so they can always rotate about this axis, but they cannot translate in either of the directions. So these joints, they only restrict translation of the joints, they do not restrict the rotation of the joints. This is again an assumption in most practical situations. So when we assume that the members are joined using smooth pins, we are saying that these joints, they do not stop the motion, the rotation of these joints. Again, this is a good assumption because most of the times these joints are very good at providing support reactions of forces, but they cannot provide a lot of couple moments. So we just say that the couple moments provided by these joints are equal to 0. So now that we have these two assumptions in place, let's look at some very simple trusses. So if we want to make the simplest truss, it should at least have 3 members, because for a truss to be rigid, each member, there should no end of a member should be free. So the simplest rigid truss would contain 3 members, and anytime we have more than 3 members, we would have this is the most simple, rigid and stable truss, and anytime we have more members, more than 3 members, that would still be a stable and a rigid truss system. So the one of the methods of analysis for truss systems is what we call the method of joints. And in the method of joints, basically we apply the equations of equilibrium on each joint, and using those equations of equilibrium we find all the unknown forces. First off, we have to understand that each member of our truss is a 2-force member, and because previously from our previous understanding we know that a 2-force member, for a 2-force member, the force should be along the line of action of the 2 points, and the 2 forces need to be equal. And so for example, if we want to analyze the forces in this truss, we would we would apply the equations of equilibrium on each joint. We would apply the equations of equilibrium on this joint, we would apply the equations of equilibrium on this joint, and we would apply the equations of equilibrium on this joint. And so we want to find the external forces, we would be using these equations of equilibrium. Okay, so the procedure of analysis when we are doing method of joints is that first of all we draw the free body diagram, and the free body diagram should contain one unknown and 2 known forces, and then we draw the free external reactions at the truss support. Whatever external reactive forces we have, we just draw all of them, and we find them using the free body diagram, and determine the correct sense of each of the member, and then we choose an appropriate axis, and then we apply the sum of all the forces in x and sum of all the forces in y on each of the joint, and then we use these equations to find all the unknown forces. So now we look at an example. So here we have this very simple truss, and we want to determine the force in each member of the truss and indicate whether the members are in tension or in compression. So we want to know if each of these member is in compression or in tension. In tension means that they are providing a pulling force, and in compression means that these members are providing a pushing force. So first of all, we draw the free body diagram of this member B, this joint B, and we see that at this point we would have 3 forces. One of the force due to this member AB, one of the force due to this member CB, and there is one external force which is 500 newtons. So this is our drawing, and now we can apply the sum of all the forces in x equation and sum of all the forces in y equation, and we can solve these 2 equations simultaneously to find FB and FBC and FBA. Again, FBA is the force along the BA member, and FBC is the force along the BC member. now we can do the same thing for the joint C, and at joint C we have this external support reaction due to the roller, and at the joint A we have these two external support reactions due to the two because we have a pin support, and we know that a pin support means that we have two external support reactions, and then we can individually solve these two equations to find the support reactions. So this is exactly the solution, and this is it for today, and I will see you in the next lecture inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.